Hello students, next let us look into the inverse Laplace transform. What is inverse Laplace transform? If you have got a function f of s, that means if you have got a Laplace function f of s and you try to take or you try to find out what is the time based function f of t, then you say that you are trying to take the inverse Laplace, which is basically given by L inverse. That's why we always write that f of t can be changed to Laplace transform f of s using Laplace transform, and similarly it can be changed from s domain or the frequency domain back to f of t. So going from time domain to the s domain or the frequency domain, we require Laplace, and going from frequency domain back to time domain, we require what is called as the Laplace inverse. Now I can give a equation for finding out the Laplace inverse, but we don't need that equation. Instead, we require two methods, or we require to study two different methods that can be useful for finding out the Laplace inverse. The first method is called as the standard results. Using standard results means we directly compare the Laplace function given to us with the chart that is given, that we have already made. So I have added some of the intermediate results that we have got in recent days. Okay, and now I have expanded this chart. So if you are getting, suppose if you are getting 1 by s minus 2, you can straight away say from looking here that it is going to be e raised to power 2t. Or suppose if you are going to get 5 divided by s square plus 25, you can directly say that its Laplace inverse will be sine phi t. Why? Because the omega value we had written there was 5. So this is the standard result which you can do the inverse. Okay, but always the result is not in this form. Sometimes the result is also given in form, let me write it here. Sometimes the result is also given in form that looks something like this. Let's say 5 divided by s plus 2 into s plus 3. Okay, 5 divided by s plus 2 into s plus 3. Let me again write 5 divided by s plus 2 into s plus 3. Now, where is the standard formula for this one written here? There is no standard formula for it. So, in those cases, what we do is we do what is called as the partial fraction method. The partial fraction method. And using the partial fraction method, we can basically find out the Laplace transform. Why? Because with the help of partial fraction method, I had just now shown you let's say, I had just now shown you that suppose if you are having a function which is 1 divided by s plus 2 into s plus 3, we can write it in this form, that it is 1 divided by s plus 2 minus of 1 divided by s plus 3. Okay, For splitting up it in this form, this is called as the partial fraction method. Now we know directly that this can be written as the Laplace inverse of this will be e raised to power minus 2t, and this one it will be e raised to power minus 3t. So what is the partial fraction method? Partial fraction method is basically kind of algebraic technique where you basically try to split up this into smaller units, of which you can directly find out the standard results. So that is why we are having the partial fraction method. Let us start with some simple standard results to find out. And you always remember, I will keep this print of chart, and you can always refer this chart and try to find the Laplace inverse. But please remember, this chart can never be taken inside the examination hall, so you have to memorize this. That is important. So let us do some of the problems of standard method. So the first method is standard result method. Standard result method, or the using standard result, it's not a method as such, it's basically directly standard, not standard, it's standard. Okay, so let's take down a question. Find the Laplace inverse of s square plus 3s plus 4 divided by s cube. Now we all know that in algebra we know that s square minus 3s plus 4 divided by s cube can be written as s square divided by s cube. Why? Because the denominator is common, correct? Minus 3s divided by s cube plus 4 divided by s cube. So what I have done, I have taken each of this and I have written it separately. Now here s square and cube will cancel, so I will get 1 by s. Here one of the s and this will cancel, so I will get 3 minus 3 by s plus 4 by s cube. 4 by s cube. This is s square, correct? Now, see, look at this chart. Now directly we have split up into smaller parts. Let's look at the chart. The chart says that you will have 1 by s, that means it is u of t. Okay, it is u of t. And if it is 1 by s square, it is t. Remember this, I have already said all the time that there will be u of t with all of these functions. Please don't forget that. U of t will be there with all of these functions. So you have to remember that. Okay. So if it is s square, it is t. And if it is s cube, you can use this one, because s cube, if this is s cube here, then obviously this one will be t square, correct? So let me write it. We know that 1 by s Laplace, let me write it in this form. U of t, the Laplace inverse is given as 1 by s, and t u of t, the Laplace inverse is given by 1 by s square, correct? And t square u of t, the Laplace inverse is given as 2 factorial, which is 2 divided by s raised to power 3. Okay. Therefore, 1 by s Laplace inverse. So let me write it in this way. Therefore, Laplace inverse of 1 by s is going to be u of t. Laplace inverse of 3 times 1 by s square. Okay, now why I have written 3 times separately here? Because here I am having 3 by s2, correct? So 3 by s2 can be written as, you all know this, 3 by s square can be written as 3 times multiplying 1 by s square. That is what I have written here. That will be 3 is this constant, so 3 will come outside. 1 by s square can be written as t u of t. And the last one is Laplace inverse of 4 times. Now 4 times can I write? No, because this is 2 by s square. So what I will do is I will first write, this is 4 by s cube, but I will first write this one. Okay, 2 by s cube, and what should be multiplied so that it becomes 4 by s cube? It should be multiplied with 2. So 2 times 2 by s cube is 2 times t square u of t. Therefore, the final answer is s square minus 3s plus 4 divided by s cube, if taken Laplace inverse, will give me an answer u of t. Okay, u of t, then it is minus, correct? This is minus in between, so minus 3t u of t, last is plus 2 times t square u of t, which can also be written as, if I take u of t common, then I will get, so I should not use this bracket, okay, I will get 1 minus 3t plus 2t square u of t. But we know that u of t is basically existing from 0 to infinity. So we can also write this as, some of the textbooks may write this as 1 minus 3t plus 2t square for t greater than 0. Because for t greater than 0 only u of t will exist and its value will be 1. So it is same as writing in this form. So you can write it in this form or this form or this form. Please don't write the answer as 1 minus 3t plus 2t square and then leave it as such. No. Either you write the whole answer multiplied with u of t, or you write for t greater than 0. So this is one of the methods of using standard result method to get the answer. Okay, let us do another problem. Another simple problem. Okay. Find the inverse Laplace transform of 3s plus 4 divided by s square plus 9. So again we know that 3s plus 4 divided by s square plus 9 is given by, or it can be split up as s square plus 9 into 3s plus 4 by s square plus 9. Now let us look at the chart and find out if there is something matching. See, in the numerator it is s square plus 9. Now where is that? Here you can see that we are having s square plus omega square. So if I am writing s square plus 9, that will be okay. But even better than that, it would be to write it as s square plus 3 square, because 3 square is 9, and then you have 3 on top. Or if you are having s on numerator, then instead of sine we can go for cos. So if you are having s in numerator, then I can write s divided by s square plus 9 square. So basically here, sorry, 3 square. So basically here I can use omega is equal to 3. So I will use this one. Okay, so what is the, we know s divided by s square plus 9, which is same as s divided by s square plus 3 square. Okay, so I will just write, we know that the Laplace of, or let's say sine, not sine, cos, isn't it? If s is there in the numerator, it is cos. So cos of 3t will give me this, and sine of 3t will give me 3 divided by s square plus 3 square. Okay, so now I can map this one to this, there is no problem, and even this one to this I can map, but there is a small problem that in the numerator here it is 4, but here it is 3. How do we solve that? So let me do that. Okay, therefore Laplace inverse of, now this one I am going to write it as 3 times s divided by s square plus 3 square is going to be equal to 3 times cos 3t, 3 times cos 3t. And now listen here, listen to this very carefully, because many people make mistake. Laplace inverse of, now I have to write it in this form. So there has to be a 4 here. But what about this 3? This 3 has to go. So I will divide it by 3 and then write multiplied with 3 divided by s square plus 3 square. See what I have done? What have I done? I have basically to take, see, I can basically use this equation. Why? Because in the numerator omega is 3. So here if I am going to write 3, then automatically here 3 will come. So there is no way that I can do away with it in this formula. So the only way to do away with this is if I divide it by 3. So here I am going to divide it by 3. So 3 and 3 will cancel basically, and I will get 4 divided by s square plus 3 square, which is basically what is written here. Okay, so that is why I have written it. So if you want to take off this value 3 and replace it with 4, you have to multiply this with 4 by 3. So that 3 and 3 cancels and 4 remains. So that is what I have done here. Now let us go back. So this is going to be 4 by 3 times sine 3t. Therefore, as the equation that the question was, 3s plus 4 divided by s square plus 9, the Laplace inverse is going to be 3 times cos 3t plus 4 by 3 times sine 3t. Is this enough? No. There is something that I have left out here. I have to write u of t, and that same will come as bracket u of t, or what is preferred in most textbooks is 3 times cos 3t plus 4 by 3 sine 3t for t greater than 0. Instead of writing u of t, you can write for t greater than 0. Okay, so this is the way in which we use the standard result method, the standard results method. Okay, now we are going to next see the partial fraction method. Partial fraction method, there are 3 4 cases. One by one we have to deal. So let me start with one of them, and then I will deal with the other three in the next class. Okay, so I will write the heading as the partial fraction method. Okay, the partial fraction method is basically for, you know, the case where you have to split the function to get it in terms of standard form. Okay, there are many different forms. There are 4 different cases, out of which today I will take only case 1. And case 1 is if the factors are linear and distinct. Linear and distinct. That means I am talking about if we take a different color, if the Laplace transform function f of s is of the form some numerator p of s divided by the denominator having s plus a into s plus b. So you can see there are 2 factors. One is s plus a and the second is s plus b at the denominator. Okay, now this can be even 3 s plus c. It can have any numbers. It does not matter. Okay. Then what this is saying is by partial fraction, by partial fraction we can find it out that p of s divided by s plus a into s plus b can be written in the form that there is some value in the numerator divided by s plus a plus some value in the numerator b divided by s plus b. So by partial fraction method we will be able to write this one in these forms: a by s plus a plus b by s plus b. How do we do that? That is something that we have to see. Okay, so by partial fraction method we can write it in this form. Now I have not written a third factor s plus c. If there is a third factor, automatically you will have to write 1 plus c divided by s plus c, but I am not writing that. Okay, so what is the technique that we use for it? Okay, what is the technique that we use for it? For understanding that, first things that we have to understand is that whatever is there in the, this thing I will separately write, that if you are having a function f of s which have some factors in the numerator, which is, let's say, s plus p1, s plus p2, like that, s plus pn. Okay, and suppose in the numerator you have the factors of form s plus z1, s plus z2, like that, s plus zm, m different values. These are not written simply as z, these are called as zeros of fs. These are called as zeros of fs. And similarly, these p's are called as the poles of fs. These are called as the poles of fs. So one way of writing this is case 1 is for simple poles. So you are having here very simple poles. which are of this format. Okay, so please you can write this somewhere. I'm not going to repeat it again. These are called as the zeros of fs. What? The numerator factors. Factors in the numerator of function fs are called as the zeros, and the denominators are called as the poles. Okay, so hoping that you have written this somewhere. These all things you might have already studied. I should actually speed up, but I'm going slow because you might have forgotten. Okay, so how do we find out? So that I will write in a different color. To find A and B. So what is the technique? A is given by multiplying. Now see here. A, the denominator is s plus A. Okay, so what we have to do is, for finding A, you use this s plus A. So you multiply s plus A, you multiply s plus A with the function f of s. Which is f of s? F of s is this one itself. So you multiply whatever is there, you multiply that with f of s. Now what is f of s? So again I will write, here, and then put the value, substitute the value, s is equal to minus p, not p, minus a, s of minus a. Why minus a? Because see, s plus a is equal to 0, therefore the value of s is equal to minus a. That is what I have written here. Okay, so basically what I am going to do, I am going to have s plus a multiplied with f of s divided by, instead of f of s, now I am going to write the full form, which is p of s, correct? So let me write that, of p of s multiplied with s plus a into s plus b. That I have to take at s is equal to minus a. S of s plus a and this s plus a will cancel off. What will remain is p of s with the denominator, whatever is remaining. So basically, if you want to find out a, you substitute here the value of s is equal to minus a after taking this one out. Let me again say, if you want to find out a, you first look at what is in the denominator, which is s plus a, you cancel that out and you write here this is equal to the finding the value at s is equal to minus a, and you will get the value of a. Thinking in similar terms, what will you have to do for finding out b? For finding out b, you look at the denominator, which is s plus b, you take that denominator out from here, and here for s you substitute s is equal to minus b. Where did you get s is equal to minus b? We got it from here. Okay. So that is a simple technique. So let me write it very neatly so that you are able to write in notebook. Okay, so if you want to find out a, this is the formula finding out a. And similarly, if you want to find out b, you have to multiply with s plus b, which is the denominator of b, capital B, into fs, and substitute s for, substitute instead of s minus b, which is basically you multiply s plus b with p of s divided by s plus a into s plus b, where s plus b and s plus b will cancel off, and you basically put s is equal to minus b, you get the answer. Okay, so let us apply this technique to a very simple problem. Okay, now is, suppose I am going to write question. Okay. Question. Find the Laplace inverse of f of s, which has in its denominator s plus 2 and s plus 3, and in its numerator it has 2. Okay, so if I want to find out, so what is the solution? So how do you write the solution? Solution using partial fraction, using partial fraction technique, using partial fraction technique, 2 divided by s plus 2 into s plus 3 can be written as a divided by s plus 2 plus b divided by s plus 3, where a can be found out if you multiply with s of s into 2, 2 divided by s plus 2 into s plus 3, where s plus 2 and s plus 2 cancels off, and here I put, since it is s plus 2, it is s is equal to minus 2, and this will give me the answer 2 divided by, instead of s I substitute minus 2 plus 3, so minus 2 plus 3 is equal to 1, so the answer of 2 is 1. Okay, now if you want to find out b, if you want to find out b, you multiply s plus 3, which is the denominator of b, with the function which is 2 divided by s plus 2 into s plus 3. Many people straight away, they know that these two are going to cancel, so many people will straight away, let me write this, s is equal to minus 3, so many people will straight away write, okay, denominator is s plus 3, so I will take out s plus 3 and I will write 2 divided by s plus 2 when s is equal to minus 3. It is same, one and the same thing. Here we will cancel off, and here we are directly written by omitting. Okay. Anyway, if I am going to write minus 3, then it will be 2 divided by minus 3 plus 2, which comes out to be minus 2. Therefore, f of s can now be written as, now for a we have got the answer 2, so I will write 2 divided by s plus 2, correct, and b I have got the answer minus 2, so I will write minus 2, or what I can do is I can take this minus and put it here. So it is going to be minus of 2 divided by s plus 3, and we know, therefore Laplace inverse of f of s, or you can write, instead of f of s you can write the whole 2 divided by, that is going to be equal to the Laplace transform or Laplace inverse of 2 divided by s plus 2 minus Laplace inverse of 2 divided by s plus 3. What is the answer? Let me write the answer here because I don't have any space now. So I will write the answer here. 2 divided by s plus 2 can be written as e raised to power minus 2t multiplied with 2. No, you have in the numerator there is a 2. Otherwise, according to the chart, it should have been always, according to the chart, it should have always been 1. But we cannot use 1. Here we are having the value as 2. So we have taken 2. Similarly here also. So it will be minus 2 times. So I will take 2 common. 2 e raised to power minus 3t bracket closed and u of t. Should not forget to write u of t. Okay, this is your Laplace transform, which is written as f of t, which is written as f of t. Okay, so this is the case 1 when we are having simple poles or the factors are linear and distinct. Distinct means they are all different. A and B values are all different. Okay, you cannot do this, or you cannot apply this method for s plus 3 multiplied with s plus 3. No, because that is s plus 3 square. That is going to be s plus 3 square. So that should not happen. Okay, so it should be distinct when the two values are different. Okay, so this is the method. Thank you.